Everyone, welcome to SMARS Fun Live. I'm your host Kevin McAleer, and today we'll be looking at creating the Range Finder cover and Range Finder holder for the SMARS robot in Fusion 360. So let me show you what it is that we're going to be looking at today. So this is our SMARS robot here, one of the many SMARS robots next to me, and this thing at the front here, this is the Range Finder that enables it to sense the distance. So I've got a small version here. So this is actually made up of two 3D printed parts. So there's the cover, and then there is the holder, which holds the is it the HC-SR07 sensor. So there we go. So what I've done is I've double checked as well using my caliper all the different measurements as well. So I think we're good to go. And let's get into it. So just before we get into Fusion, I wanted to just share this with you. One of the reasons I love robotics so much is that it brings together, you know, three disciplines, three areas of expertise, and different areas that your hobby can spin off to. Most people tend to have one area that they're quite comfortable with, and it's the other two areas where they sort of want to learn more or grow. So for me, I'm quite comfortable with the sort of programming side, somewhat on the electronic side, although that is still quite new to me. And then on the design and engineering side, I've been doing that for a couple of years now, maybe about 3 years on the 3D printing side. And most recently learning Fusion 360. So this is why I love it so much. So I think to be a roboteer in the sort of middle area here, I think you need to be bringing together your maker, you know, that's your design and engineering, electronics expertise, your programming and software engineering, hardware engineering, and your programming electronics, your tinkering. So all of these things together, I would say, makes you a roboteer. Cool. Okay, so let's crack on. Let's get into it. So what I'll do is I'll head over to smarsfan.com. Let me just bring this across. So what I've done is I've already put on to the website in the Design Studio area some of the instructions on how to do this. So today we're going to look at the Range Finder. So it'll have a link to the video once that's finished recording today. You can see it's got links to the two main profiles, and this is the first one that we'll be creating. So this is a sort of top-down view of this little part here with the key measurements. So we're going to use this. I'm just going to move that off to the side of the screen so I can do this while we work. You can see there it's got things like the parameters from Fusion 360. This just helps us be able to go in there and tweak things later on if we decide that something's not quite right or we need a tolerance, rather than just having all the parameters as we go. It's best to type them out first. And we've got a table version there. And then, as you can see on the website, it kind of takes you through step by step all the different steps. You can also download this particular profile as a PDF. You can click there for that. And that's similar with the wheels and the chassis as well. Okay, so let me just bring that back up to the top there, because that's what we're going to be creating first of all. So let me just move this off to the side. Grab the wrong window there. Okay, let's get that back. Okay, and then let me just grab, where's my window gone? There we go. Done that wrong again there. Just grab that window, move that off over here. Right, okay. So the first thing we want to do is save the file. So we're going to call this one Range Finder cover. Not cover, holder. Range Finder holder. And there we go. This time I am going to create a new component, actually, as is best practice. So this is our holder. And let's create a sketch. So let's create it on that top face there. Okay. So really it's just large rectangle. So if we just grab a rectangle and we just center that on the origin, so get that line there and click on the origin to center it, and then let's start dimensioning this. So off the diagram there, it looks like we are 50 across. Now we did say we'd start typing the parameters in first, so maybe we should do that actually. So, and this time the way that I've got OBS set up, you can actually see the windows that pop up. I think on the Wheels live stream you couldn't see this window when I was typing things in. So I just prefer to do it this way first. So the length that we've just typed in, that was 50. We have the roundness, as I call it. That's the sort of fillet we're going to apply in a minute to this sort of area here. So that's 2.5. We have the height, which is 17.5. We have the thickness, which is 2.2. We have the case thinness, and that's 2 millimeters. And on the case, that's, I'm going to show you that where this slides into place there, the case thinness is 2 millimeters. So that's what that is. Next is, there's a small triangle on here. You can see it there. Maybe you can point to it with this. So it is that small extruded part there. That's the triangle. So let's call that triangle height. And that is 2.5. Then we have the triangle width, and that is 1.5. We'll go back over these in a moment, so don't worry if you're not catching these right away. Triangle from bottom, and that's from the very bottom edge to the top of the bottom of the triangle, and that is 3.5 millimeters. And what's next? Case width, which is 46.3. That's to do with the tolerances that are applied to it. And what else we got there? The hook. So the hook is this area here where it sort of hooks round. I call it that sort of hook. Hook. Let's call it hook. And that is 3.5. And that's the gap, which is the gap between this part and this bottom part, a bit in the middle. That's the gap. That's 2.5 millimeters. We have the gap from edge, and that is 4.3. And then we have the holder height, which is, when you look at this this way round, it's that height there. Okay, so holder height. Okay, so that is 10.5 millimeters. Cool. Right, let's just change that. So that length there is our length, which is 50 millimeters, and then this one here, which is our height. Let's just get that there. Okay, right. So that's kind of making this this rectangle here. So let's zoom in on that a little bit. And what I want to do is offset from this area here by the thickness that we specified before, which is that one there, which is 2.2. Making sure that's all good. 2.2. Yep. And what I will also now do is these areas here, I'll apply the fillets to. So that and that should have our roundness applied to them. There we go. It's going to be quite a quick one, this, I think, to sketch up. Right, and then now we just need to slice those two bits that will become the hook. So let's get a measurement there. So from that edge to that edge, so that's our hook, which is 3.5, and it's the same for that distance to there. That's also the hook. Okay, and what we'll do is we'll go in there and we'll just slice off that part and that part. Okay. Now, this has made these become unconstrained again, so we might just need to go in there and dimension them. So let's just see which bit it's unhappy with. Yeah, so what we'll do is we'll just put a dimension between there, and that's our case width, sorry, thickness, and it's the same with that one and that one there. That's also the thickness. Cool. Right, so what we need to do now then is just make that so that it's not sticking up at the end, similar with that one there. Okay, what I'll do, I'll turn off the constraints just so you can see it a bit easier. Okay, what else do we need to do? Right, so the little triangle that sticks out the side is a nice easy one for us to do, so let's just sketch that out. So that distance there should be 1.5, which is our triangle width, and then the triangle height is 2.5, and then from the bottom of is the triangle from bottom, which is 3.5. So now we just need to make that edge there coincident with that edge. Let's just click those, well, that point there will do. There we go, and we just need to do the same on the other side. We could mirror it, but it's so quick to create, it's just as easy to do this. So that's our triangle width. That's our triangle height. And then we have the distance from the bottom, oops, triangle height, distance between that one and that one, which is our from bottom, which is 3.5, and then just that edge coincident with that point there. Okay, so that will grab hold of the and lock it in place, the rangefinder. So when we slide this into place, you can see that little triangle just keeps it in place there. So it's quite a small, it's not very much tolerance in that, but that's the way we want it to be. We want it to be nice and tight. Okay, so that's that part there, and then what we need to do next is just the part where it attaches to the case. So this sort of strip here where it slides onto the case. So that's just 3 rectangles. So 1, 2, 3. So let's dimension these. So this one is actually a little bit thinner because if you look at it, the edge there is just slightly in from this one. If you follow that down there, if I just do that, you can see that that edge there isn't quite flush with it. So that is our case width, I think it is. Yeah, 46.3. And that needs to be centered along that point there. So what I will do is I'll just create a little line. So X to make it a construction line. I've aligned it so that it's got the constraints to the center of the rectangle, and then what I can do is just make that so that it's collinear with the origin. So if I just do that, okay, let's do horizontal vertical with the origin. No, that's not going to work. Let's do coincident. There we go. Okay, so now we need to do the thickness of this, which is, it's 2 millimeters, but let's just grab that. So what did we call this? Case thinness, which is 2. And now these ones. So these are 2.5. So this is, did I call it the gap? 2.5, and it's the same with that one. That's also 2.5. And then the distance from that edge to that edge there is the gap from edge. Oops, gap from edge. 4.3, and that's the same for that. That's gap from edge. Okay, and then all we need to do now is just make these so that they are coincident. So that is coincident with that. Let's just zoom in a bit there. We should be able to use the collinear on this because they are 2 straight lines. There we go. Okay, and then that with that. Now, I don't think we measured that one there, so that should be 2, so it's the gap. Okay, that is the first profile complete, so let's finish that. Let's have a look at it. And then the next one is quite a straightforward thing to do. We just need to extrude it by the height. So if I just go to Q for push-pull, I start to click on the profiles that we want to move up. So I'm just going to type in holder height. And let's just get a view of the sketch so that we can continue to pull up. Just need to go back into that and continue to select the profile that we want to extrude up. Okay, that is it. Let's have a look at that. Perfect. Cool. So that's that one done. We can now move on to the cover. So let's do a new file, new design. Any questions in the stream at all? We've only got a couple of people on at the moment, I think. Please say hi. Let me know that everything's working okay. You can hear me and everything. Okay, so what we'll do now then, so this is now going to be the cover. So this is a bit more of a complicated design. Let's have a look what we've got there. So there's a few more parameters in this one that we need to create. So let's do that. So again, the length. Unfortunately, it's not bringing across the dimensions that we put in for the previous one. We could bring them across, but it's just as easy to get familiar with these things so that we understand when we're creating our own parts what these measurements are. So we've got the holder height, which was 10.5. We've got the holder arm width, which is 4 millimeters. So pretty sure, let me just measure that one to make sure that that's, look at my calipers here, I'm just going to take a quick measurement. So yeah, that's all good, so that's 4. Then we have holder, sorry, the tolerance, which is 0.2. I found that's a good general all-purpose tolerance for 3D printing for my printer, which is an Ender 3 Pro. So the depth is 16 millimeters. Tapped into the wrong place there. Okay, nearly done. Standoff, which is 8.5. The standoff is the inside there. You can see there's like a little post that's sort of sticking out. What that does is that will push against the very surface of the sensor to stop it from pushing all the way through. So it keeps the eyes, if you like, level with the front of the case. So that's what's going on there. It's stopping. Otherwise, this would go all the way through and be sort of poking out. So it's a nice design feature from Kevin Thomas there. So standoff, diameter, that's 5mm. Okay, and the roundness this time is 8mm. This is because this has got quite a curve to it. I think that's quite one of the aesthetics that makes the SMARS look so, in my opinion, so appealing. So range finder diameter, so that is 16.5, and then the distance between the two eyes, as I call them, they are eyes, aren't they? I would say they look eyes. So the eye distance is 25.5. Okay, that's our parameters done. Okay, so let's go to the next thing. So building this one. So what we will do now, this time I'll create a sketch on the front. Let's just save this and call it Range Finder Cover. And let's create a sketch on the front. So let's start with the eyes. So let's just create 2 circles. Let's make them so that they're equal in size, whatever that size is going to be. Let's make them parallel so that the origins of both of them are always parallel. And let's make the distance between the 2 centers the eye distance that we created before, which is 25.5. So now the diameter of these is 16.5, I think. There we go. And let's create a rectangle, and let's create it actually from the origin. So we'll do a center rectangle. There we go. So if we now create, I'm just trying to see what the dimensions of that is there. So this is the length that we had before, so it's 50, and then the height is 26.5, that's right. Okay, we've got some quite large fillets on these edges, so let's add these in now. So let's try to get that fillet to be on that point there. We can always add these afterwards if this is going to be a problem. Why is it selecting that there? No, that's not what I want. I shall do that when we've modelled this. So what we want now is these eyes, we want them to be sort of in the centre there. So we can make them so that they stick to that centre line there, but we also need to make sure that they are centred in the cover there. So what I shall do is create 2 X and Y lines. So I'm going to L for line, X for construction line, and I'm just going to find the center point on these lines. Let's wait for the triangle to appear. There we go. Now what we can do now, if we just bring these out for a second, what we can actually, is that locked in place there? It's locked in place there, but what we want to do is make that in the center. So what we could do, we can create a dimension from one of the areas to the center point and make that half of the eye distance. There we go. Okay. So next, what I will do now, what I found when printing these out, sometimes when you push this through here, the tolerance around the eye might make it a very tight fit. So what I think is another example here, if we just create O for offset, click on there and just apply our tolerance, we've now got very slightly larger hole for the sensor to push through. So what I'm going to do is just swap round. I'm going to make this one construction line, and the outside one, which has got our tolerance not construction line. So let's just do that as well on the other side. So O for offset, select that one there, apply our tolerance, click OK, unselect construction and select it on the inner one. There we go. That's good. And then where the holder slides into place there's like two little cutouts. So let's create them with a rectangle. So I'm just going to create a rectangle off to the side here for a second. And I'm just going to create a line going through the middle of that. So L for line, X for construction. And then what I'm going to do now is just make these collinear. So that outside with that inside one there. And you can see ever so slightly just eats into that that hole, which is right. There's the bit just where it's missing there, so we know that's correct. And that is going to be 4 millimeters. So this is the holder arm width. Yep. And the height is the arm holder height, which is 10.5. There we go. So now we just need to make sure that that is also on the center line. So at the moment it's sort of floating around there. So we just need to make sure that is collinear with the center line. There we go. That's one side done. And then let's just quickly do the same on the other side. So a rectangle, the dimension of that is the holder width, and the height is the holder height. We'll do L and X, find the middle point, create the line across, and then we just want that edge there to be collinear with that line there. We want the center line to be collinear with that center line there. And then what I'll do is I'll just make sure that these are not construction lines. So I'm just selecting it and clicking X, and that one looks okay already. So other than our fillets, that's perfect. So what I'm going to do now is I'm going to finish the sketch. So I'm going to go into our 3D view. I'm going to extrude it by the case thickness. So let's hit Q for push pull. Just select the profile, type in our case thickness. Did I not type that one in? Thickness. Let's check on the, did I miss that one there? So I'm looking for one which is 16 millimeters. We must have missed that one off. So that is the cover thickness, or depth, something like that. Actually, depth is there. What am I talking about? Let's do that again. Push, pull, depth. Boom. Now we can apply those nice rounded fillets. So that's the roundness that we're after there. So that one is roundness. So we just need to apply that same thing to the other corners. So let's just zoom out. Let's go to our fillet, and then let's just option or command select these 4 corners, edges. Okay. So nearly there. So this is going to be our front, because this is our front here. What we need to do now is spin it round onto the back and create a new profile on the back, because we need to cut into that to create the area that this will push into. So we need to create this this cutout and then add the little standoff. So just before we look at the back, we need to just go to the front again, select it, and we need to create an offset plane. And this offset plane is going to be the thickness of the case. So So what did I call that one? I called that the offset. So the offset is 4mm. So let's just add that one in there. Offset 4mm. Actually -4, but let's do that again. So we select that face there, construction offset plane, offset, and yes, it needs to be minus offset. So what that's going to do is that's going to make us so that we can create our new rectangular sketch on that plane and then extrude it forward to make the cut. So that's just one way that I chose to create this. So let's click on that profile there and let's create a sketch, and let's do slice as well. Okay, so now let's do a center rectangle from the origin, and then let's just pull that out to roughly where it's going to be. So we can actually get rid of the body now just to focus in on what we're doing. So this here is going to be, so the way that I've sketched this one out, rather than specifying the dimensions of the rectangle, I've just specified what its offset, top and bottom and all the way round from the edge. So what I've done is, if I just select that, and then can I select the top profile? I'll have to bring that in via a project. So let's select the top, bottom, and that point, and that point there. Okay, so there we go. So if I now do a dimension from that edge to that edge, and it's 3.1. So what did we call that one? We called that, did we not include that on there? Just checking on my measurements. For some reason decided not to include that one on the dimensions. Okay, let's create that one and let's call it the cover thickness. Now let's have it as 3.1mm. So that's case thickness. So let's just change that. Case thickness, cover thickness. Okay, so we got it from top to bottom. We need it from left to right. Interesting. That's because it's decided to create that dimension for us, which we didn't want. Right, so let's do that again. From there to there is the cover thickness. That's more like it. That's all we need, just those two, because the center point is already anchoring it there. So we just need to know from the edge and from the top. Okay, so now we can finish that sketch. Oops. And we can extrude that back. We need to switch the body back on so that we can see what body we're cutting into, and we can do this a couple of ways. We can either say extrude all, little cut there, or we can say to the object and select that face there. We can do that face there, I think. Right, so it's beginning to look a lot like this now. So we just need to create that standoff post. Okay, so let's click on that inner surface, create a new sketch, and this one's nice and easy. So circle from the origin, and that diameter is going to be the standoff diameter. Okay, that's that sketch done, and then we're going to pull this out. So Q to push pull that profile there, and then it's going to be the standoff depth, which is, what is that, 8 or 8.5, can't remember which. 8.5. Okay, so the last thing to do is just to apply a bit of a fillet around the edge. there's a very slight fillet. You might not even notice it, but it's rounded, that area there and that one there. And if you look at it quite closely, there is actually a curvature. It's a 1mm fillet. So if we go to modify fillet, select that edge there, and it's 1mm. Same, we need to do that edge there, and then on the other side, same top and bottom. Okay. I don't think we quite got that bottom edge. No, let's just redo that. Double click, option, and that bottom edge again, 1mm. Perfect. Okay, so that's our cover. So what I'm going to do now, I'm going to hit A for appearance. So this is our appearances pane. You couldn't see this on the last video I did because it seems to pop up out of the capture area. So now I'm just capturing an area of my screen, which makes it a lot easier to see. So I'm going to find some. What colour should we go for? Yellow plastic. We want a yellow matte plastic. There we go. Let's just drag that onto the body. There we go. That's looking pretty good. So let's save that. Okay. Now if we go back to our that holder there, we can do the same. We can A for appearance. Let's make this a white plastic. Let's find a nice white matte plastic to add to that. Save it again, and let's create a new file and then assemble the two together. So, and then we'll also bring in a model of the sensor itself, the HC-SR07 board. So I've actually got a model of that in Fusion we can bring in, and that'll help us test out if we've got all the dimensions correct and if there's any changes that we need to make. So what we will do, we'll open up our data panel. We will find our newly created rangefinder cover, so let's bring that one in. Before we do that, we just need to save this one as assembly. Right, now we can do insert into current design. There we go. Let's find the holder, and these are in alphabetical order. That's not the one we created today, so let's go back up to the top. Let's just find the holder we've just created. What did I call it? I called it rangefinder cover, so there we go, rangefinder holder. There we go, insert into current design. Should have pressed OK before we did that. Is it going to be okay about that? Is it going to have a crash on me? Sometimes it decides to crash when I do something it's not expecting. No, it's all good, all good. Okay, we can move these about in a second. So let's just rotate that round by 180 degrees. And then see there, I've got the HC-SR04. Let's also bring that in as well. That can help test out we've got all our measurements correct. So quite a nice little model, this one that somebody's put together. I think I found this one on GrabCAD. Okay, so yeah, that's looking pretty good. So let's grab that model there. M for move. I'm just going to position these roughly where I think they should be. What we can do is we can check with a cross-sectional analysis as well that we've got these correct. So if I just OK that, go to inspect, create a section analysis, and then just grab, I don't know, that plane there, and then we're just going to go through to find where our standoff is, which is about there. Okay, and it just means we can grab hold of that body and just make that nice and snug so that it's going into the case and then snug up against that pillar. Like that. Okay, so let's just have a look on that side there. So it's looking a little bit to me like that is slightly intersecting on that side, which isn't good. We can go and change that in a second if that's not right. Okay, let's turn off our cross-sectional analysis, and then let's do the same with our holder board. So we can close that data panel now so we can get more real estate. Okay, so let's just make sure this is at least aligned correctly. So M for move. Let's select the thing we want to move, which is the holder. There we go. Let's just eyeball it. It's getting close to that. That's about right. Now let's have a look on the front. That's looking good. Okay, so if we now go to the very top, we look down on that, and let's just get rid of our front cover. Yeah, I think we probably just need to move that ever so slightly. Let's just click on that. Let's just move it ever so slightly that way so it's flush against these little triangle areas. So on there it doesn't look too bad. That looks like that component is perfect. So I think it might just be the cover itself. See, that's looking alright. So we've got our tolerance around the edge there, so that's poking through perfectly. It's all aligned well. I just don't think this rectangle is quite correct. So what we can do, we can click on this and we can change the opacity of the window of the body. Let's just find the body in there. We might have to do this on... Actually, we can do it in place, can't we? So let's look at that. Let's click on the little thing. So this is a new feature of Fusion that they've added this month, where you can edit in place. It was in a preview feature beforehand, which you get by going to your preferences and looking at some of the preview features. If you look down here, whatever they're currently working on, these appear as things you can switch on. So this was a feature that they've gone live with recently, and it means you can click on something which is an assembly of other parts, and then you can edit it in place. Because what I want to do there is just change the opacity of the body, and you can only do that from within. He says, so where is the opacity? Sure, it's a right click. So we don't want any of them. There's a little window that pops out that says opacity. I can't see it on there though. Let's have a look. On there. See, opacity, I wanted that to be about 60, something like that. Makes it slightly see-through. Let's just save that, go back to our assembly, get the latest updates, because we've just saved a new version and it knows the versions are out of sync. So we'll click on that. Oh, we have to finish our edit in place first. And then do the get latest. There we go. So it's just slightly more opaque now. So we can see there it's just extruding out a little bit more than we expect it to. But the height looks perfect. It's just ever so slightly out. We do want it to be a tight-ish fit. So let's have a look and measure an actual model. This is why it's good to have your digital calipers to hand. So let's just measure the distance between left to right on there. Let's zero my calipers first. So that is 45.8. And that is... I need a new battery for this. It's going a little bit. That's 45.3. So we're talking about 0.5 millimeter that we need to increase the distance from the edge by. So if we go back to our rangefinder cover, let's find the sketch that we're interested in, which is that sketch there. Nope, not that sketch, that's the standoff. That sketch there. Right, and it's this distance from the edge. So rather than it being that cover thickness, let's do the cover thickness minus 0.5 millimeters. So it's now 2.6. Let's try that. Save that as a new version. On version 3, let's go back to our assembly and let's just get the latest update. There we go. So now we can see that is looking pretty good. I think that is good. Okay, so that's the rangefinder cover. Let's just turn off that opacity again. Let's make it 100%. Nope, wrong way around. Yeah, this is 100%. I'm confused. Something's 100% opaque. Can you see it? Must be 100%. Okay, save that. Okay, go back to our assembly. Get the latest. I don't think that's right. Let me just go back to the other one. Let's go back to the holder and just check on the opacity of that. So the opacity is 100%. So why does that still look see-through? Did I select the wrong part? Did I select the body instead of the whole thing? Yes, there we go. Okay, save, assembly, get latest. Okay, there we go. And if we forget to turn off the sketches, we can always go into the features, object visibility, and just switch them off so that we can just see what we're after. And there we go, that's our rangefinder cover. The official one has a nice little inset design there. I'll not include that on here, but it's quite trivial to do. We just need to create a triangle, create some lines that are parallel, and then slice them in. And then what you would need to think about, when this prints on the 3D printed bed, the bed's like this, and it's printed up. So anywhere where you have an area that's cut in, you need to think about how does the printer print the layer that's the top, because it's going to be printing onto thin air. So what you would do is create a 45-degree fillet just on the upper inside edge of that. And you can't really notice that when you look at it. It still looks fine, but it means when it prints, it's creating the support. So when it gets to the very top layer, it's already got something to print on. So that's a nice little thing just to think about there when you're doing your design. Okay, I think that's everything for today then. Are there any questions from the feed? If not, I shall leave it there. Please like and subscribe to the channel. That really helps me understand what it is that you what it is you like, what it is you don't like. It also means that when we create future live streams that you get notifications, so make sure you hit that little bell and set it to notification to all. If you can also leave a comment as well in the YouTube comment section, again that helps us get a bit more visibility and helps grow the channel. So thank you very much for joining me today. I shall see you probably on Tuesday for the next one, which will be the mechanical tracks. So we'll be looking at how to create these mechanical tracks on the next one. Great. Thanks everybody. I shall see you very soon.